Hello, my friends. I'm Clover, and this is Genuinely Approachable Sudoku, and today we're solving Sudoku XL by Philip Newman. This is a diagonal region sumline Sudoku. So we have normal Sudoku rules for placing the digits 1 through 9 once each in each row, each column, and each outlined 3x3 region. And then we also have diagonal Sudoku rules, meaning that along each of these two marked main diagonals, we're also placing the digits 1 through 9 once each on those diagonals. Finally, we have some region sum lines in the grid. Typical region sum line rules say that the line passes through multiple regions, and the sum of the digits within each of those regions on the line has to be always equal. However, in this particular puzzle, these are effectively just arrows, like an arrow Sudoku, if you're familiar with it. This cell is going to have to equal, for instance, the sum of these three cells. This cell will equal the sum of these three cells, and so on. So we can start by marking all of our singleton cells on these region sum lines as 6, 7, 8, or 9. And we're going to start reducing that. So this sum can't contain a 1 in it, so its minimum is 2 plus 3 plus 4, which is actually exactly 9. This also can't contain a 1 in it, so that's going to be 2, 3, 4, and be exactly 9. This sum can't have a 2 in it, so it can't be 1 plus 2 plus 3 to make 6. It can't be 1 plus 2 plus 4 to make 7. So it must be 8, which makes it 1 plus 3 plus 4. We're going to eliminate 2 from these two cells because we have 2's in those columns, which places a 2 here. The 3, 4 pair places a 2 here. The 4 resolves that. This can't be a 9. It also can't have a 2 in it, so for the same reason I explained a moment ago, that must be an 8. Which is 1 plus 3 plus 4. I have 3's in these two rows already, so I'm going to eliminate 3 from these cells, make that a 3. That's going to be a 3, and a 4, and a 3. Now, this can't be a 6, because 6 is always 1 plus 2 plus 3, which has a 3 in it. This also can't be a 6. This guy can't be a 9, because it sees a 9, and it can't be a 7, because 7 is always 1 plus 2 plus 4, which has a 4 in it. This also can't be 7 for the same reason. And I think that's all we can do with that at the moment. Let's start doing some Sudoku and see what else shakes out. So in this region, we need 5, 6, 7, and 9. There are 9's here and here. So these cells can't contain 9. So that must be our 9. So that makes this a 7, which is 1 plus 2 plus 4. 2's already see both of these cells, so that's my 2. 1 and 4. And that fills in a lot of this region. The rest of this region I need 5, 6, 8, and 9, and I have 9's in columns 7 and 9 right now. So I'm going to eliminate 9 from there, and place a 9 here. And then this is 5 or 6. That's 5, 6, or 7. This is going to be a 7. Now here, this can't be an 8 because there is an 8 in the region. So I need a 7 and a 9, and they can only go in these two cells, so that's going to be a 7-9 pair. And this is going to be a 5 and a 6. That's not a 9, that's 5, 6, or 8. Okay. These are going to contain 5, 7, and 8, and neither of these cells can have 8s because they see an 8. So that's going to be our 8. These are going to be 2, 5, 6, and 7. That can't be a 7. I'll also note while I'm here that any sum of 3 digits that sums to another Sudoku digit, other than the possibility of doing 9 equals 2 plus 3 plus 4, has to have a 1 in it. So there has to be a 1 on this line. So the 1's going to have to go there. That's the only valid position for a 1. That makes this 5, 6, or 7 to complete the row. That's not a 6 because it sees a 6. So in this row, we still need 3, 5, 7, and 8. That can't be a 3. These digits have to be relatively small. In fact, they can't be any greater than 5 because they create a sum of at maximum 8. And I can eliminate 7 from here because there is a 7 in this column. Now, right here, I still need 1, 2, and 8 to finish the row. I can't put an 8 on a sum of 3 digits that sum to a small number. So I'm going to eliminate 8 from there and make that 2, 1, and 8. And so this is either 1 plus 2 plus 4 summing to 7, or 1 plus 2 plus 6 summing to 9. So there's an 8 here. That makes this a 6, which is 1 plus 2 plus 3. I have a 2, 3 pair there. That's going to be a 2 and a 3. And that's going to be a 4 because there's a 6 there, which makes this a 7. That's now an 8. My last 2 digits in this row are 7 and 9. There's a 9 there and a 7 there. And I need 5, 6, or 8 to finish the column. And 5, 6, 8, or 9 here. I have a 9 in row 4 already, which I'll eliminate from here. So this is going to be a 9. I can eliminate 6 from these cells. There's an 8 here, so that's now 5, 2, 3, and 7. And the 6, 8 pair here gives me a 5 and a 6, and that's going to be an 8. I have a 7 in that row. 6 and 5. So now I am going to finish out the outside ring, and then I'm going to use the diagonal constraints because I think it's kind of cute to finish up the puzzle. So I still need a 1, 3, and 5 on this diagonal. Have a 3 and 5 here, so that's a naked 1. I've got a 3 here, so that's a 5. On this diagonal, it looks like I still need 2 and 4. They'll go there and there. And I still need a 6 in the region. I need an 8, a 9, and a 7. And that is how you solve Philip Newman's Sudoku XL. Hope you guys enjoyed that one. If you want to solve it yourself, the link to do so is in the description of this video. And I will see you again in 3 days.